All right, everybody, good morning. My name is Ed Kelly. My sister Erin and I are the owners of Kelly Research Technologies. It's a radionics company that's been in business since 1978, which makes us 47 years old this year. At this point, we're the world's oldest producer of two-dial Hieronymus-style radionic instruments. And I've been asked to talk to the group about, share about the analysis side of radionics and kind of lay out the basics of what that is and kind of look under the hood for a little bit and see if that might be something useful to you in your home or your operation. So I always like to start with the quote by the great Nikola Tesla. If you want to understand the universe, think of energy, frequency, and vibration. Fundamentally, we and everything around us, if you go down to that, not even the atomic level, but down to the subatomic level, everything is vibrating energy and vibration. And whether a particular string of energy feels like a tabletop or a guy walking around like this or the dinner that we're going to have in a little while, that's all a function of the frequency of those vibrations. So our key principles are everything is energy and vibration. And as a result, anything that's vibrating, so when we say vibrating, what does that mean? That means that there's a particular frequency or range of frequencies associated with each and everything that we think of in this 3D realm when we're walking around here before we go on to whatever comes next. And frequencies are just tones or music in the end. Each of us walking around is a whole symphony of frequencies that's been knitted together into a kind of a whole cloth that, again, that we think of reality. The beauty of this is that when you have energy that's radiating out, all living things are going to create a bioelectric field that we can put in our sample well, capture, amplify, analyze, and measure, and get some useful information out of it. That is a picture of a Carillion camera, which is a fancy way of saying a charged electrical plate that allows you to see the bioelectric corona that comes off of the fern plant. You can see between one and the other. It also works with animals, right, and human beings, because all living things create a bioelectric field. Now, that's a guy that sat through one of Dr. Dijkstra's talks, and you can see he's really captured the information, but maybe a little worse for the wear. So that's the nervous system in a museum where they've taken away all the tissue and skeleton and all that stuff. And you can see it really looks like an antenna with a computer on top there, right? And all of the cells in our body are working through electrical processes, and so it's not really that surprising when you think about it that every cell in the body would create a bioelectric resonance that would come off of that antenna. And this is an idea that's certainly got grounding in not only the sort of the esoteric or the new agey world. Our clients are in half and half mix of organic farmers, there we go, organic farmers and sort of esoteric people with flowers in their hair and tie-dye shirts, and it makes for a fun group when you get those meetings together. But so there's a newspaper article all the way back from the 1930s where all radio stations, Columbia scientists report, all atoms in humans or in steel found to emit and receive long-wave electrical fields or radio waves, electromagnetic signals. And there's all the articles that you might ask for. Electrographic high-frequency recording of the human informational fields. And that's out of University of California at Los Angeles, so UCLA. That was from the 80s. Even more recent than that, fields in electromagnetic spectrum emitted from human body, applications in medicine, Journal of Health, Medicine and Nursing. So you know, it's not just the hippy-dippy folks that acknowledge this. It's going on in the regular mainstream scientific realm as well. Now, the beauty of it is that inorganic matter also resonates. Again, a rock is about as solid a thing as you could think of, But when you get down to that vibrational state, even when you get down as deep as the electron microscope, you can see that rocks are of a crystalline structure. Each has a unique crystalline nature. So those are just two different minerals as seen through an electron microscope. And it's not too hard to imagine that each of these would resonate at a different core frequency or series of frequencies. There's, of course, whole octaves of information that you can use to resonate the different materials, whether it's tissue types or solids such as that. Light, sound, frequency, the fact that we all have different music that really speaks to us, that makes us want to get up out of the chair and dance or headbang or whatever it is, be filled with the spirit of faith. Each of these things, different types of music resonates for different people because we are all very similar, but also resonating in our own way. So at KRT, our radionic instruments are working within the bandwidth of almost AM radio. It's a little bit higher. If you put it on the scope, it's going to be between 7 and 8 megahertz is the waveforms that we're set to. Nothing magical about those particular, that range of bandwidth. That's just where our sort of intellectual benefactor, old T. Galen Hieronymus back in the 40s, said, well, this is a good bandwidth to use where we can look for resonant frequencies and assign different frequencies to all the different compounds that we might be interested in looking at. You know, the elements of the periodic table and so on. So what is that thing, our little instrument? At the start, you have a sample well, which is just a straight up pickup coil. It's really just a copper winding around a tube, just like you see there. And I love this picture. The one is obviously the same tube. The other is from Wikipedia. That's what a microphone looks like, just like the one I've got here on me now. With a microphone, we're trying to take a sound wave, which is a physical wave, and convert that into an electrical signal. So we also add a magnet and a diaphragm. But with our signals, we're looking at those subtle energy fields that are coming off the plant, the animal, the tissue, the rock, the calcium sample, or whatever else. And so we don't need the diaphragm and the magnet, but the pickup coil is exactly the same. When you look under the hood, you see two banks of variable plate capacitors, an amplifier, some input outputs, simple little 1930s, 40s radio technology. You know, nothing particular, all very analog. There are different hardware systems and software systems these days that also share the label of radionics, of, working within this radio bandwidth. And the beauty of them is that you can push a button and it'll spit out a readout. What I really like about ours is it's straight up analog. The testing is more of a pain. So it takes a little more time. It takes a little more training for some people, especially to get in touch with the sensations of how to read the information. But there's absolutely nobody in between you and your sample well. There's no programmer. There's no hard software that's been built in with its own agenda, you might say. It's definitely you reading your own information. And variable plate capacitors, how many of my audience here, especially, it's great to see a bunch of younger guys, but my older guys, like when I was a kid and I took apart Dad's transistor radio, what did you see on the inside? Pre-digital, all television sets and radios and radio receivers, will say, used variable plate capacitance to tune to the particular radio or television stations. They're electromechanical devices, and for our purposes, they're valuable because they work spontaneously as tuning forks. In class, I often will do a little demonstration where I'll have two tuning forks that are a perfect match to one another, middle A 440 hertz tuning forks. And I can give one a whack, and the other will start to sing spontaneously on its own as the vibration energy passes from one to the other. You've probably seen it if you've ever used a tuning fork to tune a guitar or tune a piano. That A string on the guitar will start to hum on its own when you expose it to the signal from a tuning device or from a tuning fork. So these variable plate capacitors, these little fins spontaneously start to resonate with whatever it is that's coming up the pipe from the sample well. So if we tune into the calcium for copper, or the frequency for copper or carbon or one of the other elements, those things will start to hum at whatever level of energy is present, that vibratory energy, like we saw in the earlier photo. So they're passive. They don't even require electricity to do that. They will sing spontaneously because the energy is coming from the plant. The other key part of the analysis for us in the circuit is the intensity dial, which is that fifth knob up there in the top. And if we stick with the idea that these are AM radios, that's the volume knob of our radio. Now, when we're making adjustments to our volume knob in our truck going down the road, we use our ears to say, okay, I have found some music or some information that I find pleasing, hockey scores, classical music, whatever it is. And then we use our ears to say, well, here's the appropriate volume for the kind of music or the kind of information I'm receiving right now. If it's something that's really going to pump us up, we might turn that knob up a notch. Or if it's something, you have the thing at my age where I'm in a strange area and I'm trying to read the GPS, well, I have to turn the volume down to make my eyes work better, right? Have you had that? So I don't want to go too far into the weeds, but it is important to just explain in a simple way. The intensity dial is a variable resistor. That just means that when that dial is at 0, there's 0 ohms of resistance in the circuit. And when I go all the way around to 100, that gives us 50,000 ohms of resistance. It's just it's a potentiometer. Now, because we're gathering through the input well, and then whatever signals we've added through the signal input port, and then the tuning banks with the variable capacitors, there's going to be a point where we're turning this variable resistor, at which there's a resonance feedback loop created when the strength of all those inputs equals the resistance we've introduced artificially with that dial. And resonance feedback loop is a fancy way of describing a phenomena that we are all painfully familiar with, where you've got a performer or someone like me that's up on a stage using live amplification. So I have this input device right here, and the speakers are in the ceiling, so it's probably not even going to happen in this room, but if the speakers were on stage, like up on stands, if I get too close to those speakers, what happens? And you can hear it spooling up, right? That big squeal, and if the person with the microphone doesn't move, boy, it's nasty, and the crowd will usually like, hey, get out of the. And the interesting thing, it's just the same as our circuit, except in that case, the resistance is the literal space on the stage. It's when the strength of the inputs through the microphone equal the strength of the outputs through that speaker stand. If those are in the exact right spot, you get that resonance feedback loop. Well, that's just what our instruments do. I've even got a picture of that. But because we're working up in 7 to 8 megahertz, it wouldn't matter how good your ears are, you're never going to hear that, right? Our ears are not adjusted to be able to hear from most people, some people can, a few people can, but most of us tap out at like 20,000 cycles. So instead what we do is we use that human antenna to sense that resonance feedback loop by putting our fingertips on the output device of the instrument, which is the antenna. And there's the little simple one there that you see with the black top, and then there's the fancier one there where you can see the coil underneath. But it's a scalar antenna from it's Tesla's 1894 biflor coil antenna patent. That's exactly where that comes from. And so we're going to run our human antenna, our fingertips across that plate while we turn that intensity dial and see if we can sense through our electric system, through our antenna, where that resonance feedback loop is. Now, for many years, that was the most woo-woo thing about radionics. You start telling people, well, you rub your fingers on a thing and it sounds like you're inviting them to a seance practically, right? Some years back, we found an article, 1953, the journal Science, which is the sort of the top of the heap in terms of mainstream scientific literature in the United States, maybe the world. So an engineer named McElroth found that if the dry skin of one's finger is moved gently over a smooth metal surface covered by an insulating layer, and the metal is connected to the undergrounded side of, in his case, 110 power, the surface has a characteristic feeling that disappears when the voltage is disconnected. Now, the way that happened, like many great scientific discoveries, is McElroth was laying in bed and reached over to turn off the lamp on the bedside stand there. And, you know, this is the old, it's the 50s still, so it's those, you remember the brass fixture with the little knob right there. And it had been waxed, so you had an insulating surface, which was probably what saved him from getting 110 run right through him, because there was a ground fault in the lamp. So he felt that when you turn the switch off, there was a buzz in that brass surface, and when you turned it off, that buzz went away. And like great engineers and scientists all through history, he said, instead of just blowing it off, he said, oh, this is interesting, what can we find out about this? Ends up publishing this paper, and it led us to, you know, this is just from a few years ago, this description of this idea, and you can see there the principles of capacitive touch sensing. You've got the fingertip there. You've got a protective overlay, which could be plastic or glass. You've got the copper pad where the charged plate is, and then you've got a printed circuit board where the detection is happening. Well, that's all well and good. We've never, you know, what the heck are we talking about there? That's how smartphones work. That's how when you pull out your smartphone and touch the surface and then swipe to unlock, and then we press little icons to get various pieces of software to run or to input you know, information as we type in things or play a game or dial a number. In that case, the computer inside the phone is detecting your capacitance as you come down and touch the surface there, your electrical field. How well does your phone work as far as opening it up when you've got gloves on? Not that great usually, right? That's why, because it's reading your electrical field. And with our instruments, it's you are the computer and you're reading the electrical field that's coming out of the instrument when you get that resonance feedback loop. So, when you get down to the actual testing, so that's how those things work. That's how the instruments work under the hood. Fundamentally, the analysis, and we'll just whisk right through this part because it's the easiest part. Well, all we're doing is putting different things in the sample well and see whether they get, again, louder or softer together. I've got a soil sample in the well, and then I add and take a reading. How loud is this? So maybe I get a reading of 50. Well, I've got 10 different corn samples that I'm thinking of planting. Number one, throw it in the well, take another reading. It goes down to 40. Well, that corn and that soil have an innately dissonant relationship, right? Those two are not making a good harmony together. They're making a sour note together. On the other hand, we go to sample number two, take another reading. So we've got your soil and sample number two, and those, it goes from 50 to 60. It's just a relativistic scale. It's not parts per million. It's just, did this energy field get louder or softer? And so those two have an innately harmonic relationship. We're measuring that on the dial because now the resonance feedback loop is 10 more than the last one. And so you can go through the chart there and put all kinds of different combinations together and simply see over and over again, sample A by itself, does it get louder or softer when I add the second thing? And because everything is electrical and everything has a vibratory property, you can throw anything in the well. You can throw cocktails of things in the well because at our place, it's not just A plus B. It's A plus B plus C plus D plus E, you know, et cetera, et cetera. So you can put together whole, again, almost symphonies of different combinations and see how these all work together so that you can analyze and figure out ahead of time for very little cost and only a few minutes of your time, which is indeed the most precious resource of all, whether a particular combination is working well together or not. And then you can go work with your consultant to say, hey, you know, this is really tested well. Now let's talk about the real world details of how much and when and that sort of thing. You know, these are just little measuring devices, so it's a tool in your toolbox to gather information, but then you have to use your own expertise and the expertise of your consultants to know what to do next. The other type of analysis that you can do is a more comprehensive analysis, where we have organized worksheets that are organized around different themes. Those pairs of numbers are the 2 dial rates. You'd set 9 on one dial, 49 on the other dial, and then tune in and get a relative sense of the general vitality of a particular plant or animal. You can go down through the whole chart and take a whole bunch of readings and start to get a picture of what's going on in your situation. And then again, from there, by itself, may or may not be that valuable. It's up to you to then take the information and do something with it. So that's a lightning fast, quick overview of how radionic analysis works. It really is just radio waves resonating and looking at the intrinsic vibratory fields that are coming off of us and everybody else. Thank you very much for your time. I appreciate all your attention and goodwill.